Welcome to ClickMyProject.com. Our project title: An optimized algorithm for association rule mining using FP tree. Our project abstract: data mining is used to deal with the huge size of data stored in the database to extract the desired information and knowledge. It has various techniques for the extraction of data. Association rule mining is the most effective data mining technique among them. It discovers hidden or desired pattern from large amount of data. Among the existing techniques, the frequent pattern growth (FP growth) algorithm is the most efficient algorithm in finding out the desired association rule. It scans the database only twice for the processing. The issue with the FP growth algorithm is that it generates a huge number of conditional FP tree. In the proposed work, we have designed a new technique which mines out all the frequent item sets without the generation of the conditional FP tree. Unlike FP tree, it scans the database only once, which reduces the time efficiency of the algorithm. It also finds out the frequency of the frequent item sets to find out the desired association rules. Our data flow diagram. In this data flow diagram, it consists of a data mining process. It consists of a three processes called pre-processing, classification and clustering. In this process, it mentioned that pre-processing and classifications can be used. In the first, we want to select the dataset selection. The dataset selection consists of datasets. It contains the set of data in the databases in the server. For example, it contains the cancer institution of a datasets, and the datasets can be selected and it can be updated in the database related to the separate selections like classification. It mentioned the users details and the related process smoke details, etc. After that, the data sets can be converted into the details and can be taken to the pre-processing methodology. In the pre-processing methodology, the null values and the unwanted data sets can be removed from the pre-processing methodologies, and the data can be updated from in the servers related to the databases, and the related values can be predicted. The values can be contain the transaction values like the normal values or the random values. It contains the limiter values of a preprocessed data sets, and the values can be compared with the preprocessed data sets or finalized data sets. It can be further proceed to the processed. In this process, we used the FP growth algorithm to calculate the predicted values and the high utility algorithm to calculate the certain ranges for the related datasets. The datasets can be classified with the compared dataset values. The values can be compared to the finalized dataset to mention the transaction values, and the classified datasets can be re-updated into the database, and it can be mentioned that the predicted values can be mentioned. The transaction values can be gained from the compared datasets values, and the high utility datasets can be compared. In the high utility datasets, it contains the finalized values of the predicted datasets as an input of the users. The users can be given a certain datasets for know about the finalized predicted values. It mentioned that the certain ratio of the datasets contained in the databases. Our project demo. for an optimized algorithm for association rule mining using FP tree. To start our process, first click on the home.java, right click on it and click run file. This is our home page. Click on any of place in the home page. After that, we want to load the dataset. For example, it's an input of our processor. Click on the browse, click the pathology and select all the files in a pathology folder. It's an input. It contains a PDF file and it can be converted into a text file to read in it. It can be loaded into a database. It contains the reports and the attributes. The attributes can be mentioned that the it's user details and the name details and the user detailed reports. And the related clinical data sets can be stored. It contains the user details and the user cancer details and the age, for example male or female, etc. It can be loaded into a database. This can be loaded and the pre-processing methodologies can be done. In the pre-processing process, it can be remove the null values or example unwanted data sets. This is the data pre-processed. After pre-process, it remove the unwanted data and the null values. After that, the data comparison can be done. In the data comparison, the clinical and the pathological data sets can be compared and the report and the ID can be generated. This mentions the gender and the age and the smokers reference. For example, reference 0 mentioned that the never smokers and the limit age of the smokers. In this process, we mention the high utility algorithm. For example, we want to predict the values for FP growth algorithm and high utility algorithm. In the process mentioned that the high utility algorithm. This is the high utility selection. For this data set, we can find the using the high utility algorithm. We have find the predicted values. This is the related attribute description. For every attribute, the descriptions can be mentioned. For example, T1 is a tumor size for less than 3 cm and the chain smokers or never smokers or reformed smokers, etc. In this graph, it mentions the efficiency of the, for example, storage efficiency. FP growth, it contains the more storage space in the database and the server. In the HU utility algorithm we used, it reduced the storage space for and generating the report. In the FP growth, it generates every user reports for every details. In the HUA utility, it reduces the generations and it predicts certain values. In this process, it mentioned the comparison of every attributes. For example, FP growth and the high utility algorithm. For every efficiency values, it can be mentioned. In this graph, it mentioned the datasets efficiency. For FP growth, it analyzes the low efficiency of analysis. In high utility algorithm, it makes the largest analysis to give the prediction values for every user's attributes. Thank you.